Everything was working. The app was running, you made a few changes, and then, in just one moment, everything disappeared. So you did what almost every beginner does. You started making backups. A few days later, you weren't protecting your project anymore. You were trying to figure out which one was actually the right one. And then, things got even worse. Imagine working on the same project with 2, 5, or even 100 developers. Thousands of files, hundreds of changes, every single day. Somehow, they don't overwrite each other's work. They don't lose progress. They can even travel back in time to any version of their project with just a few clicks. That isn't magic. It's GitHub. And by the end of this masterclass, you'll understand exactly how it works. From repositories, commits, branches, pull requests, and everything in between. No confusing jargon, no skipped steps. Just one complete guide to the tool that millions of developers use every single day. Let's get started. Before we open our terminal or click a single button on GitHub, let's clear up the single biggest point of confusion for beginners. What is the difference between Git and GitHub, and why do you need both? Git is a free, local version of control system running directly on your computer. Think of Git like a high-powered camera. Every time you make a major change to your code, Git takes a local snapshot and stores it in a hidden vault inside your project folder. It works 100% offline. GitHub, on the other hand, is a cloud hosting service for those Git snapshots. Think of GitHub like Google Photos or iCloud for your code vault. Why do we need both? Git keeps track of your history locally on your machine, but if your laptop breaks, your local Git history disappears with it. GitHub takes your local Git vault and uploads it online so it's backed up, accessible from anywhere, and ready to share with potential employers or teammates. Every command we run today follows a simple 4-step path. You write code on your machine, working directory. You pick which changes to pack, staging area. You seal the snapshot locally, local repository. You upload the snapshot to the cloud, GitHub Remote. Now that you have the mental model locked in, let's jump in hands-on, setting up your GitHub account and creating your very first remote repository. All right, let's jump right into the actual tutorial. To get started, head over to github.com. Click on the Sign Up button in the top right corner. You can create an account using your email or quickly sign up using your Google or Apple account. For this tutorial, I'll go ahead and select Continue with Google. Once you finish authenticating, you will see a page like this, where you can review your email, set your unique global username, make sure it is available, otherwise choose a different one. Then choose your country and hit Create Account. You'll land on your main GitHub dashboard. This is your mission control center, where all your repositories, activity, and contributions will live. Now, let's create our very first remote repository. Click the green New button on the left sidebar, or click the plus icon in the top header and select New Repository. After that, you can find a page like this, where you can specify the repository name, description, and repository configuration. First, type in your repository name. Choose something descriptive, lowercase. For this example, I'm calling it Demo. Right below, you'll see the optional description field. Adding a concise summary here helps teammates and recruiters quickly understand what your project does. Next, select your visibility. Public. Anyone on the internet can see your code and learn from it. Perfect for open source work and showcasing your portfolio. Private. Only you and specific collaborators you invite can view or contribute. Ideal for proprietary, client, or in-development work. For my case, I'm using it private now, but we will change it later on. Under Initialize this repository, check Add a README file. A README is the landing page of your repository. It's written in Markdown and acts as the instruction manual for your project, explaining how to install, run, and use your application. If you toggle on the button, a default README will create alongside with this repository, but now I'm going with no README as default. Next is the .gitignore dropdown. This creates a special file that tells Git which files or folders to ignore so they never get committed to GitHub. You can select pre-built templates for your specific stack, like Node.js, Python, or Go, to automatically exclude heavy folders like node modules, .env secret files, or build artifacts. For now, I'm going with default no gitignore. We'll learn about it later. Finally, pick an open source license. The license determines how others are legally allowed to use, modify, or distribute your code. You can choose MIT or Apache 2.0 or even any license based on your project. But for now, going with default no license. Once everything is set, hit Create Repository, and your remote vault is live on the cloud. Congratulations! You just created your very first repository. Right now, it's completely empty, so we need to take the code from our local computer, track it with Git, and push it up to GitHub. GitHub gives us two paths here, depending on where you're starting. Path 1, starting completely fresh from scratch on your computer. Path 2, connecting an existing project you've already been working on locally. Since we're building from scratch, let's follow the first set of commands and get our project live. Before we initialize our project, we need to make sure Git is installed on your machine. Open your terminal and type git version. If a version number pops up, you're good to go. If not, don't worry. You can check out my previous video where I walk you through the whole installation step by step. To initialize our project, let's start by creating a new folder called Demo. Right-click the folder and select Open with VS Code. Once VS Code opens, open Terminal by pressing Ctrl+J in Windows or Command+J on Mac. Now type git init and hit Enter. Notice what just happened. Git initialized a brand new empty repository right here on our local machine. Next, let's create a new index.html file in VS Code and add a basic HTML heading. Now go back to your terminal, type git status, and hit Enter. You'll see index.html highlighted in red as an untracked file. What does this actually mean? It means we created the file in our local working area, but Git hasn't saved a permanent snapshot of it yet. To save it, we first need to move index.html into the staging area, our draft box. In your terminal, type git add period and press Enter. The dot tells Git to stage all changed files. Now for the final step, saving our permanent snapshot. Type git commit -m, add index.html page, and hit Enter. This locks our staged changes safely into our local repository vault. Now that our local commit is saved, let's switch back to the GitHub cheat sheet in our browser and review what we've done so far. Just like GitHub suggested, we initialized our project, created a file, an index.html instead of a README, and committed it with a clear message. Next, GitHub shows the command git branch -m main. This command renames your active branch to main. As you can see in VS Code, our default branch is already set to main. But if your terminal shows master instead, go ahead and run git branch -m main, so your branch matches GitHub standard. Now comes a super important step. Git remote add origin, and then the link to your repository. In order to connect your local repository vault to your online GitHub account, Git needs to know the exact online web address to send the files to. That's what this command does. It assigns the nickname origin to your online repository address. Copy the exact command from your GitHub page, paste it into your terminal, and hit Enter. Finally, we reach the big moment. Command number 3. Git push -u origin main. Let's break down what this actually means. Git push tells Git to upload your local commits to the cloud. Origin is the nickname of the GitHub web address we just set up. Main is the local branch we are pushing. And the -u flag stands for Upstream. It tells Git, remember this connection so that next time I only have to type git push. Press enter to run it. If this is your first time pushing to GitHub from your computer, a pop-up window will appear asking you to authenticate. Simply click Sign in with your browser. It will redirect you to GitHub in your browser. Click the green Authorize Git Ecosystem button. Once you see the Authentication Successful message, switch back to your terminal. You'll see Git finishing the upload. Now, go back to your browser, refresh your GitHub page, and boom! Your index.html file and your exact commit history are now live on the internet. Congratulations! You just completed the core GitHub workflow. You've mastered the fundamentals, and from this point on, you'll never lose your code again. Now that our project is linked to GitHub, let's see how daily updates work. Let's create a new file named readme.md in VS Code and add some basic project description text. Open your terminal and run git status. Notice how Git highlights readme.md in red. It's an untracked change sitting in our working directory. Let's stage and commit it through VS Code Git GUI. To add, click on the Git icon, and then beside the untracked file, you will find a plus icon. Just click it to add in stage area. Then you will find a text box like this. Type your commit message, and then click Commit button. After that, you can push the code by clicking Sync Changes button. But let's try it. Let's try the terminal one more time. Now, to upload this snapshot to GitHub, we don't need to type out git push-u origin main like we did the first time. All we need to run is git push. Why? Because the -u flag we used earlier set the upstream tracking. It told Git to remember that our local main branch is permanently linked to origin/main on GitHub. So from now on, a simple git push is all you need. If we switch over to GitHub and refresh the page, boom! Our readme.md file is live on the homepage. Now let's talk about branches. What is a branch? Think of a branch as an isolated copy of your codebase. Why do we need it? Imagine you want to build a new About page for your website. If you edit code directly on the main branch and introduce a bug, your live website breaks for everyone. To prevent that, you create a feature branch where you can safely experiment, build, and test without touching live code. Let's check our active branches in the terminal by running git branch. You'll see main listed in green with a little asterisk next to it. This means main is currently our only branch and it's active. Let's create our new feature branch by typing git checkout-b feature-about. The checkout command switches branches, and the -b flag tells Git to create the branch first. Run git branch again, and look at that. We now have 2 branches, and the green asterisk has moved to feature-about. Now, let's create an about.html file in VS Code and add some basic HTML tags. This time, instead of using the terminal to save our snapshot, let's use the VS Code source control UI. Click the source control icon on the left sidebar. Click the plus icon next to about.html to stage it. Type your commit message in the message box and click Commit. Our snapshot is now safely locked inside our local feature-about branch. Now, let's try running a simple git push in the terminal. And we get an error. Why did this fail? Because GitHub doesn't know this brand new feature-about branch exists yet. Remember, every time you create a brand new branch locally, you have to establish its upstream link to GitHub on the very first push. Luckily, Git gives us the exact command to run right inside the error message. Copy and run git push --upstream origin feature-about, or the shortcut git push -u origin feature-about. Now head over to GitHub. Click the branch dropdown near the top. You'll see both main and feature-about. Switch to feature-about, and there is your about.html file living safely in its own isolated branch. Now we run into a big question. Our about page is finished inside feature about, but how do we get that code into our primary main branch? On your local machine, you could simply switch to main by typing git checkout main, and then run git merge feature about. But in real-world software engineering, merging directly on your machine is considered risky. Nobody gets a chance to verify your code, check for security bugs, or test it before it reaches production. That brings us to pull requests, PRs. What is a pull request? A pull request is an online proposal on GitHub asking your team to review, test, and approve your feature branch before it gets merged into main. Why do teams rely on pull requests? Code reviews. Senior developers and teammates can inspect your code line by line, point out potential bugs, and suggest cleaner ways to write it. Automated testing, or CI/CD. Automated tools like GitHub Actions can run tests in the background to guarantee your new code doesn't break existing features. Conflict resolution. If another developer edited the exact same file while you were working, GitHub flags the merge conflict so you can resolve it safely before merging. Let's switch back to GitHub and create our very first pull request step by step. To create a pull request, head over to GitHub. You'll see a prominent banner at the top reading feature-about had recent pushes. Simply click the green Compare and Pull Request button. Alternatively, you can click the Pull Requests tab at the top of your repository and click the green New Pull Request button. Now, pay close attention to this next step. It's the most important part of creating a PR. Look at the two branch dropdowns at the top. Base branch, set this to main, or whichever target branch you want to merge your code into. Compare branch, set this to feature-about, the branch containing your new code. This explicitly tells GitHub, take the changes from feature-about and merge them into main. Next, give your pull request a clear, descriptive title. Below the title, you'll find the description box. This is where you write a concise overview of what you changed, why you changed it, and how to test it. Adding a solid description helps your code reviewers quickly understand your changes, so they can approve your PR faster. Once your title and description are filled out, click the green Create Pull Request button. Congratulations! Your pull request is now official, and your team can review, test, and merge your code into main. Now comes one of the most interesting parts of pull requests, code review. On the right sidebar of your PR, you'll find a quick control menu. Reviewers, request specific teammates to review your code. Assignees, assign the developer responsible for managing this PR. Labels and milestones, categorize your PR, like enhancements, documentation. Let's simulate a real code review. Click on the Files Changed tab near the top. Here, GitHub gives you a line-by-line breakdown of your changes. Green highlights represent new code added, while red highlights show lines deleted. Since about.html is a brand new file, the entire block is highlighted in green. You can leave feedback on exact lines of code. Hover over any line number, click the blue plus icon, and a comment box pops up. Let's leave a review comment. It would be nice if you added a descriptive paragraph below this heading. Click Start a Review or Add Single Comment. Now click the green Finish Your Review button at the top right. You'll see a pop-up offering 3 review choices. Comment, general feedback without explicit approval or rejection. Approve, gives the green light to merge the code. Request changes, formally blocks the merge until the author addresses your requested fixes. Type a quick summary in the box, select Request Changes, and click Submit Review. Switch back to the Conversation tab. Your requested change is now officially tracked on the PR timeline. Now, let's fix it. Head back to VS Code, make sure you are still on your feature-about branch, and open about.html. Add a paragraph tag, P, below your heading, save the file, and commit and push your update to GitHub. switch back to your pull request page on GitHub. Notice how GitHub automatically updates the PR timeline with your latest commit? Click Resolve Conversation on the review comment to mark the feedback as resolved. Now that all requested changes are fixed and approved, it's time to merge. Click the big green Merge Pull Request button, then click Confirm Merge. Boom! Your feature about code is now safely integrated into your primary main branch on GitHub. Once a branch is merged, keeping it around creates clutter. Let's delete the feature about branch, both on GitHub and locally. On GitHub, select the dropdown and click All Branch. Click the Delete Branch button. Even though the branch is deleted, its complete commit history is permanently saved under the Closed tab on the Pull Requests page. On your local computer, open your terminal in VS Code. First, switch back to your main branch, git checkout main. Then delete your local feature branch safely by running git branch-d feature about. Running git branch confirms feature about is completely gone. To bring those merged GitHub changes back down to your local machine, run git pull. Look at your file tree now. About.html instantly appears in your local project folder. That is the complete back and forth sync cycle of Git and GitHub. Create a branch, push to GitHub, review and merge via pull request, pull updates back to local main. Running git branch confirms feature about is completely gone. Now, remember earlier when we created this repository as private? Let's say you're ready to share your code with the world. Put it on your resume, or share it with potential employers. How do you make it public? In your repository menu on GitHub, click the settings icon at the top. Scroll all the way down to the bottom to find the danger zone. Here, click Change Visibility and select Change to Public. Confirm the prompt, and just like that, your repository is public. Anyone on the internet can now view your code and star your project. Now that your code is public, there's a vital security step you must know. Never push sensitive data or unnecessary files to GitHub. This includes secret API keys, .env files, passwords, or massive build folders like node modules. How do we prevent Git from tracking these files? Using a .gitignore file. Let's see how it works hands-on in VS Code. Create a file named .gitignore in your project root. Now, create a dummy file named styles.css. Look at your source control tab. Git highlights styles.css as a new untracked change. Now, open .gitignore, type styles.css inside it, and save. Look back at source control. Styles.css instantly vanishes from Git tracking. What if you want to ignore an entire directory instead of single files? Let's create a folder named build and place an app.css file inside it. Git flags it as tracked. Now, open .gitignore and add /build/ on a new line. Immediately, the entire build folder and every single file inside it are ignored. Let's commit and push our .gitignore file to GitHub. Over on GitHub, you'll see our .gitignore is live, while styles.css and the build folder were safely excluded. Now comes the absolute superpower of Git and GitHub: disaster recovery and cloning. Imagine your laptop breaks, or you accidentally delete your local project folder. Let's simulate this worst-case scenario. Close VS Code, and let's permanently delete our local project folder from our computer. Are we doomed? Not at all, because our complete project history is safely backed up on GitHub. Let's download a fresh copy onto our computer using git clone. On your GitHub repository homepage, click the green Code button. You'll see 3 protocol choices. HTTPS, the simplest method, uses a standard URL link. Best for beginners. SSH uses secure SSH keys, so you don't have to enter credentials repeatedly. GitHub CLI uses GitHub's official command line tool. For now, select HTTPS and click the copy icon next to the repository URL. Open a terminal on your computer where you want to store your project, type git clone, paste the copied URL next to it, and press enter. In a matter of seconds, Git downloads your entire repository, including every file, branch, and commit history. Open the cloned folder in VS Code, and everything is right back to where you left it. That proves it. As long as your code is on GitHub, you will never lose your work again. Finally, let's look at how to permanently delete a repository on GitHub if you ever need to clean up old practice projects. Go to Settings, scroll down to the Danger Zone, and click Delete this repository. GitHub will ask you to type the full repository name to confirm deletion. Warning: once you delete a repository on GitHub, it cannot be restored from the cloud, unless you still have a local copy on your computer. And that's a wrap. You have officially mastered the complete core workflow of Git and GitHub, from initializing repos and tracking commits, to branching, opening pull requests, code reviews, and remote syncing. The best way to lock in these skills is to keep practicing them on your daily projects. In our next lesson, we'll dive deeper into GitHub issues, collaborator permissions, and automated CI/CD workflows. If you found this guide helpful, hit that like button, subscribe to the channel, and drop any questions in the comments below. Thanks for watching, and I'll see you in the next masterclass.